This is the autonomous golf cart with a concentration on steering and stereo camera position. My name is Christopher Teti, and I'm a mechanical engineering major.
My name is Ty Kao, and I'm a mechanical engineering major.
The issues for this project we want to target is that to provide transportation for student, faculties, and especially disability people in society. According to the 2017 Disability and Statistic Annual Report, there are 39 million people have reported disability in a wide range, such as vision, cognitive, and cell health. The project is aimed to help university to provide transportation to students at any given time, like late at night or for students to go to their cars when they park really far.
Deep neural network are used widely because of their ability to learn from the given data. Deep neural network is a complex algorithm, and they are similar to a human brain. They basically recognize the right thing to do after they learn it from an expert. A popular method for this technology is supervised learning. This basically means the network will give a required input or task to the machine and will provide a desired output so that the machine can function on its own after.
Here we have the steering column modifications. The first thing to be done was to remove the steering column, and the second part was to add the power steering motor. The reason we want to add a power steering motor is to make it easier for the golf cart to turn itself once we get it working autonomously in the future. To do this, we needed to cut a section out of the original steering column where the power steering motor would fit, and there would be a U-joint connector on the top and bottom of the motor so it could fit and be connected to the original shaft.
Bracket support. So the bracket were made to support the steering motor because it's very heavy. Two brackets were measured and sketched using Fusion 360 to create a CAD model. A CAD model is computer aided design. So we're gonna use that design and then we're gonna go to create it in a aluminum material to provide more strength to support the motor.
Here we have the steering sensor. The steering sensor is basically a potentiometer that works with the steering wheel for our situation. Once the steering wheel turns, it produces a voltage that is sent to the ECU. The ECU is an electronic control unit that will determine the exact angle of the steering wheel based off of the voltage that was sent to it from the potentiometer. This will allow the golf cart to turn accurately when we want it to autonomously. Here we have the stereo camera and roof rack. The roof rack was designed by us in a CAD called SolidWorks. We designed it specifically to hold some of the electronics that will sit on top of the golf cart. The most notable electronic that we want to use is going to be the Z stereo camera. This will be our main peripheral for the golf cart. It's going to be used to see what the golf cart sees. The reason we chose this camera is because it has two eyes similar to a human, and it has 110 degrees of view, and it has the ability to analyze depth maps and depth confidence just like a human can. These pictures just represent what the Z camera sees, similar to a human. You have a right eye and a left eye. You can see different angles if you close each eye. So this is just a representation of how the Z camera is actually seeing.
So these pictures below are the depth maps and depth confidence. Because of the ability that the camera have two lenses, it can have a better depth perception when it comes to analyze depth. Depth map is basically the how far the object is to the camera. And as you can see on the left, black color is further away and white color is closer. And on the right is the depth confidence. It's basically is how accurately far away the object is the camera thinks. So the white is more confident and the black is less confident.
Here are the final results that we found for our golf cart. In the left picture, we have the bottom of the steering column connected to the U-joint. In the right picture, we have the power steering motor connected to the upper part of the column and U-joint. We don't have the brackets yet. They are being machine shopped now. We expect them to be done by the end of March. As for the Z camera and the roof rack, we expect that to be assembled and completed by the end of April. Our end goal is to have the Z camera steer the golf cart autonomously using machine learning with the techniques described in the system control section.